Welcome back to P1. Today we're looking at Unit 3, which is equations and inequalities, and the start of that is looking at linear simultaneous equations. Now, this is a GCSE topic, or IGCSE topic, so it shouldn't be anything new. It's more about refreshing your memory for this one, and you can solve these either using elimination or substitution. And you should end up with a single pair of solutions, or answers, if you will. So what I'm going to do is I'm going to look at the same two equations, and we're going to do it elimination method, and then we're going to do it substitution method. So first things first, whether I'm doing elimination or substitution, I should label my equations 1 and 2. Now, to do the elimination method, I need to make either the x's or the y's equal in size. So I can either need to make the 2 and the 4, the 2x and the 4x essentially equivalent in size, or the y's equivalent in size. Okay, I'm not worried about signs, but just equivalent in the size of the shape, the magnitude. So what I'm going to do is I'm going to start by multiplying this first equation by 2. So if I do that, I'm going to get 4x minus 2y equals 12. And this is now my new equation. So equation 1 is being replaced by equation 3. And then what I need to do is, looking at these two, these are the same size. And if they have the same sign, then I need to subtract. So I'm going to do equation 2 take away equation 3. So 4x take away 4x is 0. 3y minus negative 2y, that's going to be 5y. And 22 take away 12 is going to give me 10. So I've got 5y equals 10, so y equals 2. Now I've got my y equals 2, I need to substitute that back in, so I'm going to substitute y equals 2, and any equation will do, and I'm going to use equation 1. So when I substitute that in, I get 2x minus 2 equals 6. So that means that 2x is going to be equal to 8, x will therefore equal to 4. So here are my answers, essentially 4 and 2 for my x and y. Now I can do a check, and in that one I'm going to use the other equation. So let's check. So if I look at my left hand side, I've got 4 lots of 4 plus 3 lots of 2 when I substitute in 4 and 2, and that's going to give me 16 plus 6, which is 22, and you can see that that does equal the right hand side. So my check is complete. Okay, so that's elimination method. Now I'm going to go back and just redo the elimination method just in case you made the y's equal in size. So if I multiplied this first one by 3, okay, I could have made the y's equal in size. So this gives me a new equation 3. Now when I look at these, the y's are the same size, but they have different signs. Different signs means I add, so I'm adding. So 6x plus 4x is 10x, 3y plus negative 3y is 0, 22 plus 18 is 40. So 10x equals 40, so x equals 4, which is what we got the first time. And then again, it's just a matter of subbing this into one of my equations. I'm going to put it into equation 1. So 2 lots of 4 minus y equals 6. 8 minus y equals 6. And you can see there that y is 2. I won't do the check in this one because I'm just doing it a second time, but just to show you, you could have made the y's equal. Okay, substitution method. So substitution method involves me rearranging one of my equations. So what I'm going to do is I'm going to rearrange equation 1. So we had 2x minus y equals 6. Now y is a single unknown there. There's no coefficient in front of it, so it makes my life a bit easier. So what I want to do is make this y equals, so 2x is now y plus 6, so y is going to be 2x minus 6. Now I'm going to substitute this into my equation 2, my other equation. So that means I've got 4x plus 3. Now instead of y, I've got 2x minus 6, and that equals 22. So expand my brackets, 4x plus 6x minus 18 equals 22. And you can see here I'm going to have 10x equals 40. So just like before, x is going to be equal to 4. And again, once I've got my first answer, the second part of solving this is the same every time, whichever method you use. So I just need to then substitute x equals 4 into any one of my equations. Now, I'm going to call that one equation 3, and that's where I'm going to substitute it in, as it's already rearranged for y. So y equals 2 lots of 4 minus 6. So 8 minus 6, 2. Y equals 2. And there we have 4, 2, as we did previously. Okay? So what you should be good at is that you should be able to use both methods. You should be able to look at a question and decide which one's going to be the quickest and easiest to do. Now, in general, if you have a letter where there's no number in front of it, it's often quite quick to do the substitution method for that. Okay, but it does depend on how they pair up. In general, I think the elimination method is often the quickest or the easiest, provided these pair up nicely. Now I'm going to give you a few to try yourself. So you can see in this case I needed to actually multiply both equations by a number so that I could have numbers to eliminate that were the same size. Okay, and this is perfectly fine as long as you multiply everything in the equation by a chosen number, it will stay as an equivalent equation. So now we've got equation 3 and equation 4. Now, just based on the numbers, I'm going to do 4 subtract 3. So 6x take away 6x is 0. 10y take away 9y is y. And 36 take away 33 is 3. So we got y equals 3 as my first answer. Next I just need to substitute that in. So I'll skip little bits ahead now. Okay, with this equation, the first step is to rearrange both of these equations. So I want to get in the form 3x minus 2y equals negative 5, because I want in the form of kind of an a plus b equals c. Expanding this one, we've got 5x plus 5y equals 6x plus 6. So if I take the 6x across, take away 6x I should say, get minus x plus 5y equals 6. And therefore I have my two equations. I'll just pop the answers up. Okay, let's have a look at this question. So I'm just going to get a bit of room there. equation 1, equation 2, this times this one by 2, so 6x plus 2ky equals 16. Now it means that if I add my equations 3 and 2, the 2ky's will cancel. Okay, this is how I can work out part A. So I'm adding equation 2 to equation 3. So x plus 6x is 7x, the minus ky, 2ky plus 2ky is 0, and 5 plus 16 is 21. So x there is 3. And we've shown part A correct. Now part B then tells us that y is a half. So if I start with from equation 1, or even from equation 2, doesn't really matter. I can go from equation 2. Again, doesn't matter. So x is 3, so we had x minus 2ky equals 5. X is 3, y is a half. So we got 3 minus k equals 5. The k is going to be negative 2. So first step here is to substitute in my x equals q, my y equals 1. So 2q plus p equals 5. That is that original equation here. And looking at my second equation, I'd have 4q minus 5 plus q equals 0. So we've got 5q minus 5 equals 0. And that is there my second equation. Now from this second equation, it contains no values of p. So it means I can actually find out the value of q. So let's carry this on. And q is going to be equal to 1. And then sub q equals 1 into equation 1. And we get 2 lots of 1 plus p equals 5. So p is going to be equal to 3. And that's it, really straightforward. Okay, so linear simultaneous equations is just an IGCSE or GCSE topic. Hopefully you shouldn't have too many problems with this one. But please like, subscribe if you haven't already, and come back in for the next video on quadratic simultaneous equations.